World without physics or the fear of life, from Christian Herminau. The answer to life. How many particles does life need? When does it begin and where does it end? Is death the end or the beginning of everything? Is it perhaps a new beginning, each time on a slightly higher level? Perhaps even a rebirth? But then what holds the dissolving atoms together after death? Or is it only the spirit, the knowledge of the old personality that is passed on? Are the great religions right when they speak of the soul or even of rebirth? Only, is such a thing conceivable? Is there anything in this universe that can overlook or even influence these countless particles, control them in any way? Does somebody or something want it to go always forward, always higher, to become as complex as possible? Who is interested in this and who helps with it? And can it then still run according to physical laws, be created entirely from itself? Human beings of the genus Homo have been around for perhaps 2.8 million years, according to the oldest lower jaw found in Ethiopia in the Afar sink. The complex animals and plants even date back 650 million years, but for simple, unicellular or even more elementary life, we can fall back on periods of time that run into the billions, almost to the beginning of the Earth itself. No sooner had the Earth calmed down after the Great Bombardment, no sooner had the conditions on it become more hospitable, than the first extremely simple life, the seed for everything later, appeared, or so it is thought. But where did it come from so quickly? Did it come from outside? Was it brought to Earth with the meteorites, or does life always develop in the same way? If the conditions are reasonably favorable, is everything just waiting to be able to finally get started? It is there, the solution to it, the answer to the question of life, thinking and also consciousness, everything is within reach. It is actually right in front of us, has been visible to all of us for a long time, if you want to see it, and yet the knowledge about it disappears immediately, as soon as you suspect something and want to grasp after it. We cannot simply believe what we see, we are not prepared for it, so we have to work slower and not tell the story from behind. Particles are supercomputers. The world's fastest computer can handle up to 143 petaflops per second or 1.43 10 to 17 operations in a single second. That sounds an incredible amount when you look at the bare numbers, but a single particle has 10 to 18 connections with other particles per second. Does that mean that every elementary particle is a supercomputer and far superior to our high-performance computers? Such an exchange between particles is only elementary, only one small piece of information is exchanged at a time, but even in computers we only have relays that are linked together and have only one piece of information in them, on or off. After all, each particle leaves behind a real small mass or energy packet in the other particle after an exchange, i.e. something foreign remains in the respective counterpart. More and more small foreign masses collect in the particle, a small memory. So not only the abstract information, 1 or 0, like in a relay, but something from another particle coming from a completely different area of space, sometimes a really distant information. It gives something away and it takes something in. The amount of energy is tiny and always the same, and yet it does not seem to us to be the same as with a computer. Maybe the amount of energy is the same, but maybe there is something more of the foreign particle in it, something that only belongs to the foreign particle and has to be returned sometime, at the latest when time reverses and everything is undone. If this is the case, then such an exchange is in no way comparable to a computer. Then we can, or rather we must, try to create an image, an analogy from the living. For example, a child growing up and getting to know more and more of the world, absorbing impressions and strangeness, which slowly become more and more familiar to him. Children slowly become more and more multilayered and start to think independently. They later feel themselves to be independent personalities who seemingly make their decisions freely. Viewed more radically, the elementary particle could also be understood as the smallest living structure of matter. This smallest unit emits some matter and absorbs some in the same measure. It gives something of its own life to the other person, cuts out a tiny piece, a little knowledge, a little information, but not of something lifeless like a number, but of something that was empty and inanimate only at the beginning, but which with time gained tremendously and finally became inert. Particles grow, not in size, but in inertia. They feed on other particles and become heavy, although they give off as much as they take in. One particle fills itself with others and fills others, it crosslinks. Inert mass is the expression for the degree of interconnectedness, the amount of information and the network to which the particle belongs. And yet an inert particle that becomes increasingly inert is a finite particle over time, a particle in which the initial timelessness, which is immediately broken down to a slower finiteness. We need time if we want to experience the world consciously. Moreover, each particle has a gigantic memory. Everything is registered and recorded chronologically. Probably again only in an absolutely simple form, but it is more than happened in computers, because there the memories are independent of the processor. They have to be controlled separately and they are not just zeros or ones, but with particles it is something of the other. And probably the reading out of information is not a stringing together or a driving along an information chain, but the memory is read out as a whole, as a block. It is a capture of an overall pattern that is immediately and abruptly there. This means that if we had access to the innermost part of the particles, a single particle could easily outrun the world's largest computer. From the beginning it is already stranger than the machine and has in its germ much more of the later living structure. It seems to be just as simple and plain as the machine, and yet on closer inspection it is so much different. The harmony in physics. Of course we have no access, on the contrary, we are more willing to assume in physics that these abilities are only illusions that disappear behind the uncertainty than to believe that there is such a potential in individual particles, because then we would have to upset everything, think everything over again, because it is not the formulas that are wrong, but the approach, the basic approach itself is already wrong. All physical formulas assume that the world functions mathematically and is analytic in essence. And always the formulas and equations, even the great theories, work perfectly well. The equations fit the experiment or are made to fit appropriately, and that is all physicists want. No confusing worlds, no unnecessary complication and no confusing complexity. That is why everything higher, holistic or extremely networked is analyzed until only the elementary basic building blocks and the elementary laws can be seen. A clear structure that is as simple as possible, symmetrical and harmonious. Only that physicists fail again and again when they want to put things together, when they want to take something larger and more alive with them in some way. But even the simplest building blocks such as elementary particles and atoms prove to be stubborn in detail, just as even the large structures only want to fit in part. The mathematical equations become more and more complex, the additional assumptions to hold the unit become more and more abstruse. It is a unit of analytical methodology, preferably a single analytical formula that describes everything. They hope that this exists and that only they hold the key to it in their hands. In this way, physicists retain the sovereignty of interpretation about the fundamental questions. Everything that was eternally firmly in the hands of theology now submits to science. Only science may judge truth and lies, what belongs to physics and what is dismissed as metaphysics. Only pure science is allowed to ask the deepest questions of existence, questions about where from and where to, although, as we claim, it is wrong from the very beginning about physics, and it itself knows how many open threads simply cannot be connected. Another consideration is that it is much easier to create a simulated world than a real one. Especially if living intelligent objects are to be included in it. Real processes in our universe are slow and inert. They take their time for everything. Mathematical particles move according to the Gaussian distribution and physical gases or in general any physical thermal system in equilibrium are treated according to the Boltzmann statistics. This means that if there are only a few particles, it can happen within a reasonable time in a closed space that all particles are at the same place. The more particles there are, the less chance, or better, the longer it takes before something like this happens. But particles that happen to be at the same place are by no means orderly structured particles. To achieve this we would have to wait much longer. Moreover, there is no linear temporal connection between a rare state and the duration of time, but the probabilities of this happening decrease exponentially, i.e. it becomes increasingly improbable, the durations of time virtually explode. Actually, the dimensions we are dealing with in terms of the number of particles are beyond any measure of time. We would then have to juggle with numbers that are so incomprehensibly large that they can no longer be written down. Even such an ordered structure, as we see it in a unicellular organism, can no longer be statistically recorded in numbers for the quantity of mathematical atoms. Understanding particles. The situation is completely different when we are not dealing with mathematical particles but with understanding particles. In comparison to statistical particles, it would be easy to agree and assume an exclusive state. Yes, in agreement, any state, however improbable, can be assumed if everyone is in exchange with each other and agrees on a movement or directed change. This is especially easy with humans. We are impulse and energy independent in our movements and can therefore move in space as we wish, guided only by our thoughts. A command from a regent and any number of people gather in a fixed place. Communicative particles have to change and calculate more in order to keep to the laws of impulse and energy and still be able to gather in one place. This means that even communicative particles must gain an overview of the whole and cleverly calculate how to use the laws of conservation in such a way that a consciously controlled movement results. It needs an intelligence already at this point. Mathematical particles have no intelligence and never get it. With them, special features become increasingly unlikely with increasing particle numbers. Their only chance of change lies in the Boltzmann distribution, which has an exponential course and quickly produces only ever greater improbabilities. With communicative particles with memory it is exactly the opposite. The more particles are involved, the sooner patterns can emerge from the networks, and through constant trial and error and observation, over time, a knowledge of themselves and a knowledge of how to influence networks can develop. Such highly resonant small evolving superparticles represent something completely different from the elementary particles of quantum mechanics. But such interesting processes do not work in our macroscopic world. If we take real spheres and set them in motion in an experiment, then they behave statistically in a purely mathematical way. Such large objects always behave like dead bodies. In this rigid connection, we experience the world as a continuously mathematical process. But even with atomic spheres moving in a closed space, we do not see their peculiarity when we observe them with our worldly devices. Then the physical world with its mathematical statistics and the energy and conservation of momentum is still in order. The problem is also that our brains cannot imagine completely different foreign mechanisms. Our conception of the world is based on the sluggish slow matter world of our reality. And for all complex and simple life, nothing else was ever possible to think or perceive. Only with modern research does the bizarre world of atoms open up to us, which is so strange that at least physicists have given up trying to describe it with words. They grasp and observe something that functions completely differently than anything that has ever existed before, something that leaves them speechless and bursts their imaginations. They try to forcefully transfer the formulas from their everyday world to the world in the smallest detail and realize that they then have to get involved in contradictory and irrational things. In fact, the phenomena can be described and calculated mathematically correctly, but they cannot be understood in this way. And worst of all, there is no interface to life. With this fundamental approach, life can only be explained by infinities. If you break the chains of time, the number of universes, the possibility of concentrating energy and matter in the smallest space, then life should also be somehow possible somewhere, so the researchers tell us, they imagine, because they have no better explanation. Within the infinity they wait until every possible probability has been played through once. Time has no meaning anymore. But with infinities we can always explain everything in an emergency. God is also infinite, infinitely kind, infinitely powerful and infinitely knowing. We have fallen into the trap of mathematics, we have mathematized physics and celebrated our successes. In the end, we are so deeply anchored in the old worldviews that all we have left is the infinities as argumentation. But what we see, what we have found out, is not infinite. Not in any way. It is large, unimaginably large and numerous, but not infinite. Our body is undeniably complex, but does not behave irrationally. On the contrary, despite its versatility, everything in it seems to be coordinated, almost like a melodious harmony. The universe is large but explorable, and we have been setting the boundaries for some time. Atoms are small and there are so many of them, but not infinitely many. The world around us explodes everything tangible, both large and small, but it is not infinite, even if most of it is unreachable. We will probably never be able to reach other solar systems or communicate with an atom, but with our minds we can imagine everything. Much more than is actually possible. In virtual simulations the possibilities are almost inexhaustible, anything can be. This is where we have to start, this is where we have to change the narrative to free ourselves from the trap of mathematics. The story we are told must not mean that particles are fuzzy, unpredictable and free. Free particles do not create life. Life is a harmonious interaction of the many. Life is versatile, varied and always unexpectedly different. It is the fantasy of thought that has become reality. This universe does not function mathematically. It is not the laws of gravity and electrodynamics that have created this diversity. It is the thinking of the particles, their ability to exchange and network. Virtual thinking must be much more widespread in the universe. It is easier to create particles with our way of thinking and it has the potential to influence celestial mechanics. It is extremely computationally demanding to oppose entropy, but it is possible in reasonable time with particle intelligence that is beyond our imagination in its dimensions to think things up before they are slowly and painstakingly implemented in the real world. Thinking particles highly interconnected, that is where we have to start, then the problems with the creation of life should solve themselves. What is wrong with the mathematical universe? We have a wrong idea of how movements are consciously controlled. We want to go somewhere, so we get up and go. But the laws of physics do not work as simply as we are used to. If we want to move in a directed way from rest, we have to use energy and we have to leave something behind, something that points exactly in the opposite direction, the impulse. In the case of elementary particles this is obvious, but in our own case we only notice that we get hungry when we march for a long time or that we only get further on solid, well-adhering ground. If we had to walk on an ice surface, we would have much more difficulties to push ourselves off. The more frictionless the transition between shoes and ground is, the more difficult it is for us to move forward, because we cannot give a proper counter-impulse. Such problems are much more obvious with particles than with us, in our world. Most movements are only possible in connection with other particles. An air molecule only moves forward if it can repel another, which is then ready to move backwards. If we have many particles, all of which move at a basic speed, we quickly notice that it becomes very difficult for a single particle to assume a very specific speed and direction. We would say it has to wait until it happens by chance. The Big Bang Theory is also faced with this dilemma, because after the dramatic initial conditions, a larger space would quickly open up in which a kind of primordial gas, hydrogen, would spread out evenly. A simple gas, that cools slowly and in which the atoms move according to the Boltzmann distribution. Some of them move faster, others slower, most of them at medium speed or, what is the same, at medium temperature. Here we can already sense immediately that this would look completely different with communicative, networked and thinking particles. But let us stick to our mathematical approach. According to Boltzmann, despite the size of the standard universe, we have few possibilities in the standard universe for matter to accumulate randomly at certain points or to possibly cluster into smaller and larger stars. In the mathematical universe, such mass accumulations would be something quite rare, despite their size. Apart from the speed distribution, which is the only variety that allows such a universe to have the most varied speeds and directions, other states of order are only the exception. A second great destroyer of any order lies in the law of entropy. Again, this is a law that is mathematical through and is derived from statistics. Physically, a higher state of order always requires some energy. The mathematical interpretation of nature considers the things that happen out of themselves as possibilities. The number of possibilities can only ever increase. Therefore one says, in a closed system the entropy always only increases. If we have a beautifully ordered state, for example a vase, then there is exactly this one arrangement of atoms and exactly that which belongs to the order of the vase. If it were to fall off the table, there would be many more possibilities of what would be created. We would then have not only one arrangement of atoms, but a multitude of arrangements. But also the shards could change over millions of years to smaller and smaller fragments of themselves, until in the end only the atoms themselves are left. There is a clear direction of the arrow of time to smaller and smaller particles, which become more and more confusing. The number of possibilities only increases. This is exactly the problem with the standard universe. Galaxies, stars and planets would never form by themselves, just as atoms never form a vase by themselves. But it is easy for a potter to form a vase out of clay within a few minutes. On the one hand, there are the free mathematical atoms where we would have to wait eons of years to create a vase by chance, according to Boltzmann, and on the other hand, there is the potter who, from unreal statistics, shapes things according to her imagination with great ease within seconds and minutes. Dark matter, dark energy. In order not to overstress the improbability and infinities, physicists have developed an accelerator, dark matter. Not that every universe would then immediately have something as versatile as ours, but the probabilities increase if there is something that affects ordinary baryonic matter and accumulates matter around it like a germ. Only there are two serious problems. Firstly, this dark matter itself should already be structured, only a heavy germ would not be enough, and secondly, despite intensive searches, it has not been found directly up to now. Nevertheless, everything that now goes against the laws of distribution is attributed to dark matter. For example, that it came at all so fast and so frequently to the galaxy formation is from now on because of the dark matter, which lies like a gigantic halo around it and influences the movement. Of course, in such a way that it corresponds to the measured values. Gravitational lensing effects are caused by the dark matter, but even more dramatically, the filament-like arrangement of galaxies around gigantic voids is also caused by the dark matter. These filaments are enormously large order structures that run counter to any mathematical statistics. Such a thing would never come into being by itself, or, according to Boltzmann, only in eons of years. The trick is, as long as nobody knows what this unknown matter is, it does not have to follow any rules. If physicists think that something becomes visible through the filaments of which one does not know what it is exactly, one does not need to ask why this foreign matter can do something that normal matter cannot do. Namely, violate the laws of entropy. Another at least equally unsolved question is what is driving the universe apart, because we are not dealing with a single explosion, but with something that stretches space itself. And we are still dealing with it today. A mysterious dark energy that is much more powerful than anything else stretches space, and with it everything in it, and as the space expands, the number of possibilities increases, and with it the entropy. For particles, even if they do nothing else, the entropy increases continuously because space expands. But in principle not the space is expanding, but it becomes bigger for the particles. A jump or a movement in it can now be divided into smaller and smaller steps. Since we assume according to quantum mechanics that everything happens by leaps and bounds, a continuous expansion would be the wrong picture. Because on the one hand, there is always something infinite in something continuous, a continuous infinitely fine expansion, and on the other hand, if the jump or the step size of a particle or the distance between the particles also expanded, the number of steps would remain the same. So space divides itself more and more, but this does not affect the particles in it. In this way, we can explain why the galaxies seem to be moving away, but not why we need energy to do so. Space does not necessarily have to push the galaxies in front of it can also simply divide. But the way the theory is laid out, space seems to be something, and to have contact with matter is probably in some kind of interacting relationship with it. This is what relativity predicts, but how can matter, and even more so light, move in it so frictionless, and what reacts to space? Isn't it the particles, these smallest units of matter, that change space? Why do the galaxies move away from us, but where space meets the particle nothing happens? Why does everything here remain the same? The questions about dark energy and how we should imagine it are even more unsolved than those about dark matter. Dark energy can still be everything and does not seem to have to orient itself to anything, nor is it used at all for the universe as a whole without going into the details. No wonder that it is also a thorn in the side of so many physicists, and that such doubt are repeatedly expressed in publications. But let us go back to dark matter. If dark matter is in any way even mathematical, i.e. functions according to mathematical laws, then we again have the problem that many more stars and galaxies would have to form around these nuclei than we observe in the universe, and these objects would then have to be much more similar. The galaxies would have to be smaller, but more frequent and even more similar. Mathematical universes simply create too much symmetry and a too similar structure. Chaos is missing. They lack the really interesting events, but we can clearly observe them in the real universe. They are there and cannot simply be left out. At the latest in the computer simulations we see the dilemma. Physicists and even more so mathematicians think in too structured a way and look for the patterns of order alone, preferably the universal. And this is exactly how the worldviews are laid out: clean, logical, as symmetrical as possible, mathematically beautiful and simple. They like to summarize the many things. The movement in space is described by its center of gravity, i.e. a single numerical value instead of billions of individual masses. It works, you can do it very well, but then they generalize and create a universal world theory on this basis, which other people from outside the field then take as a basis, and that is exactly the mistake. We can use simplifications very well for our calculations, but only for that. It is then a technical universe, and as we can see it is extremely powerful, but it has nothing to do with life and the extraordinary nature of the divine universe, which we have completely forgotten with all the success of our technology and our superior intellect. What is special on Earth is not its center of mass and its movement through space. What is special is the nature of each individual atom, its idiosyncratic arrangement and its relationship to each other. They all together create the Earth, and this can only be understood from the whole. The most unusual thing about it is not that we can make a simple movement out of it, but much more astonishing is that we manage to deal with this multiplicity and the daily chaos that result from it. In somnambulistic security we do not only move through a chaotic space, but unconsciously recognize extremely complex connections. We recognize them, develop a feeling for them and experience them as pleasure. We experience it, as the tip of the iceberg, this summary of endless information, as the lightness of life. But back again to dark matter. In contrast to the formation of galaxies, it is impossible for nuclear fusion deep inside the suns, despite all the euphoria, that dark matter still be here present. Suns produce higher atoms, and the periodic table of the elements is not only ingeniously devised, it is also the prerequisite for simple and higher life. Here, completely against entropy, simple elementary particles such as protons and neutrons are brought together and fused to higher ordered nuclei in complicated procedures. This results in ever larger and ever more complicated atoms that do not immediately disintegrate again. They remain stable, and then much later, for example on planets, together with the electrons in the shell they form stable neutral atoms, which are much more capable than the components of which they are composed. They are special complex ordered states in a world which, according to theory, should only love the lower things in life, if it really only works mathematically. No matter how we turn things around, the mathematical approach always leads us into a dead end. We see that there are states of matter that should never have happened by themselves, but they are there. Nor do they arise as a one-time event, but it seems to be the normal state. The whole physical simple elementary world is strikingly too versatile and varied. It is completely against all basic assumptions, completely against all theories. If we stick to the analytical approach, then our universe is unique. Can so many physicists be wrong? It is hard to believe that so many intelligent people are all supposed to be wrong. All the more so when you look at the technology that emerged from this very rational analytical mathematical science. Doesn't it indirectly confirm that the worldviews behind it must also be correct? Could sophisticated technical machines function at all if the formulas behind them are wrong? The trick is that it is not the formulas that are wrong, but the basic approach. A mathematically designed universe works very well. Many theories work very well, and in many areas they also match reality. If we are dealing with matter from our environment, then we can wonderfully apply Newton's laws to it. If we want a holistic picture of large mass systems in the universe, then general relativity is an excellent tool. The basic structures of the framework in this universe are masses, charges, momentum and energy, or space and time. As long as we move in this area, the world is in order. We can rely on the fact that no vase will be created from broken glass by itself. We observe the first big break when we go into the very smallest. Firstly, there is no smooth transition, and secondly, phenomena suddenly appear here that require completely new formulas and connections. For example, electrons in the atom move on radiation-free paths. They can only reach higher orbits if the energy is exactly right. The continuity of space and time is violated, energy or momentum moves only in portions. Or, what is worse, the whereabouts of particles that were stable up to that point are blurred and their further progress is uncertain. The physicists have quickly learned to adjust to this new bizarre world and have actually found formulas that fit, and thus made the world of quanta controllable again. Planck's quantum of action now shows us the lower limit of accuracy or measurability. If we keep to it, then the formulas and equations are again analytically valid, they believe. For actually the statements of quantum mechanics are only of statistical nature, mathematically calculable, but no longer analytical, but only stochastic. Nevertheless, theorists still dream of the one formula that describes everything, with the only restriction that they no longer believe that this miracle formula is simple. It will then be a very complex, extremely complicated formula or system of equations that only very few exquisite people can understand, similar to Einstein's general theory of relativity at the time. We can see that the laws, including those of quantum mechanics, work quite well. They cannot describe everything, and the individual disciplines often cannot be combined, but they do help us to move forward. But if you ask yourself why the world of the smallest is quantized, why particles have these freedoms, or why the universe is so versatile, we have no answer. Then these mathematical formulae do not fit the many galaxies and stars that are spinning too fast, and the whole worldview behind them collapses. Because the world is not pure geometry, as Galileo already wished. Regardless of whether the very great personalities such as Galileo, Newton, Einstein, or many important physicists such as Maxwell, Bohr, Heisenberg, Pauli, Fermi and many others firmly believed in it and set the milestones, they always trusted in the absolute truth of mathematics, which is hidden in the physical world. But, what if it is not pure mathematics that rules the world, but life, thinking, or perhaps even consciousness? On Earth it is obvious, everything on Earth is dominated by life, but in all other parts of the universe this does not seem to be the case, but in this, we think, the researchers are wrong. All the seemingly perfectly functioning laws out there are influenced by thinking. The real matter seems to move bluntly according to the basic laws of mechanics, and in fact we will probably not be able to prove an obvious break in it. Nevertheless, it seems possible, through elaborate calculations, to intuitively make matter behave against entropy. Matter can seem to move in a directional way, but it must not be observed. An atom that is observed in our world, localized at a certain place, such an atom is stuck. There is then so long no future for this particle. Only when we have lost it does time continue to move in space for the particle. If we take our world as an inertial system and control the matter in it, then we are helplessly at the mercy of the laws of impulse and energy conservation. We then see exactly what we want to see. But if we go one step further and assume that all particles are small living beings that constantly exchange with each other and have a plan, then these thoughts cannot be implemented in the same way as with us humans, but the desire of matter to assume a certain state runs through the network like a spirit and leads to the fact that the whole thing changes slowly in a directional way. If we are satisfied with our life, we will not change anything in our everyday life and then nothing will change. But if we suddenly feel that we are too fat, for example, this can lead to us losing weight at some point. Thoughts alone cannot directly cause anything. Just because we want to be thinner, we do not lose weight and certainly not immediately. But a thought can make us change our behavior, eat something else or only at certain times, and that would have an effect. Our mind has no direct access to the cells. Conscious thinking happens independently of what happens in the cells, and yet nothing would ever change in the state of the body unless a new thought were to arise in consciousness. Other intelligences. We would not immediately sense anything from an intelligence or a consciousness in the universe, not like a telephone call. Our body cells would not know about our mind either. Nevertheless, something can only stand up against destructive entropy in a reasonable time if it is intelligent. But if we have intelligent systems in the universe, even if they only arise in particle networks, then the sluggishly slow sequence of statistical coincidences changes dramatically. In simulations on computers, models can be calculated at a speed and with ease that cannot be compared with anything else. We would have a theoretical evolutionary accelerator that changes everything. Suddenly ideas are there without end and it is all about implementation. How can we use the sluggish slow building blocks to change the world a little, to redesign and develop it further? If our particles are much more than spheres or mathematical objects, if they can be compared more closely to quantum computers, then a multitude of intelligences have formed very early on, all of which are interested in the transformation of matter, each in its own way. Then positions have to be determined and recorded, movements and energies have to be analyzed and evaluated, and then slowly influence the laws of nature to achieve the desired result. This requires a lot of patience, because unlike superfast thinking, the world of matter moves according to our laws and time sequences, which are very slow and finite. Only, we claim, this spiritual influence on matter goes through intuition. This means that matter is not moved by small switches and currents as in transistors. Thoughts are created in the networks like in quantum computer, they are intuitive, not static. That means that the interface to the inert particle is also intuitive. The network a particle belongs to slowly changes its cohesion. Huge numbers of particles must join together and slowly change in order to initiate a strategic movement as a whole. These calculations behind it, that capture all the atoms and their interactions, are of such large dimensions that we have difficulty imagining such a thing. Can these particle intelligences make these big calculations? Perhaps it is better to take a comparison again with the living, conscious one. We feel our body and our personality as a closed unit, even though we, as adults with about 70 kilograms, consist of at least 10 to 28 elementary particles, which all belong to our body and cannot simply do what they want. Our body functions as a whole. It forms a unit, with the special feature that this unit has a consciousness, it feels the whole. We feel as one personality, not as many, and we have the feeling to control things and not that we are controlled by the many. If we look at a beautiful landscape, then millions of rods and cones take the world on the retina as pixels and transmit them as electrical impulses to the brain. In the brain, it is not the 120 million individual pixels of the rods and the 6 million cones that are passed on to consciousness, but the picture as a whole. Not the pixels are the information that is stored, but the picture itself, an interpretation of it. And also this holistic picture is then not in us like a photo on the hard disk, but it is of dynamic liveliness in us. We look up and capture the landscape with all its details. If we see it consciously, if it is a beautiful day and a beautiful landscape, then we feel good, enjoy the warmth, the wind and the sounds, perceive everything. We believe that it is only our ego that looks around attentively, sees the image of the landscape, but in the moment when we consciously look at something, an unbelievably big world holds its breath. We can feel it, sometimes we perceive this many things in us even unconsciously, and when particles form living networks and work together in extremely large numbers, then this feeling of being composed of many things is not just imaginary, but fits in with a physics that also functions according to mathematical laws, but not only. Our one consciousness then consists of much small intelligences, which not only creates unity but also participate in it. If it should exist, why should it look away? And if these particle networks do not exist, who or what makes us consciously perceive the world? We believe that the genes store our genetic information and that our nerve cells in the brain, in just a few years, can teach us to learn a language, control the local motor system, absorb culture or learn to understand an incredibly diverse environment. No sooner has the brain been conceived as an embryo than a rudimentary consciousness sets in. Cells divide, specialize, and after a few weeks a small heart takes over a network of blood systems and starts beating. Each eye cell knows where it belongs. At each division not only the single cell knows what its task is, but also all atoms with it. In a temporary exponential growth, each cell is assigned its special task. It knows when it is its turn and how it has to divide further, and this only because it is in our genes. It is asking a lot to believe. Can DNA store everything? It is true that DNA is very large and, compared to a hard disk, the information is written on it so compactly that researchers are trying to use it as storage elements. Storing information on the gene code would be much more compact and secure than on silicon chips. But in an embryo, the information has to be read out at the right place all the time, and something has to know where something is when and provide the appropriate nutrients and molecules for the division. It is an incredibly complex process, which no supercomputer could calculate from the outside, but which is supposed to happen from the individual cell without central control. The cell knows about it because it has a gene code in it that has been activated. Who would believe such a thing? According to science, cells are made up of dead matter, mathematical atoms, protons and electrons which only fulfill the physical conditions as will-less objects. On the other hand, there is a cell, which in somnambulistic certainty, knows exactly what to do to create an extremely complex whole, namely a human. We take a zygote, prick it once and it magically starts to divide and divide, again and again, and out comes not a big cell clump but a human being. Like a computer program that runs and conjures up small fractal objects that become more and more alive. It is a beautiful story, but it is told wrong. Although we can be there under the microscope when this miracle happens, we can see with our own eyes how life is created from a few cells. Is the story not true? It is like the black holes with the counterforces. If matter contracts because gravity is only attractive, never repulsive, and if at some point all the energy reserves in the big suns are used up, then at some point there is no counterforce to the ever-increasing mass attraction. If there is no counterforce, then matter collapses and, if the theory of relativity is correct, forms a black hole. Then we have a state of matter in the universe, which is the logical consequence in mathematical universes, but in a universe where there is life, this should not happen. Although both the Big Bang and many fundamental relationships have not yet been solved correctly and there are still many open questions, physicists believe that something as surreal as a black hole is possible. Instead of thinking about what is wrong with the formulas, they try to prove the existence of black holes with a lot of energy and effort, as if the survival of the greatest theories of physics depended on it. We see that the galaxies all move too fast at their edges, that there must be unknown forces that are not of Newtonian nature. We know that there is something we have not understood about the galaxies and that the dark matter hypothesis, which has been sought for 60 years, is a fallacy. But in the scientific community, black holes in the centers of galaxies are real, and the photograph almost proves it. We see it, the whole world sees it, and we hear that it is a black hole and that it looks exactly like the simulations. And yet there can only be a gigantically ordered mass accumulation here, which does not cross the event horizon, but rather an ordered, non-radiating state of matter that goes beyond anything imaginable. If every particle is really thinking for itself and initiates insane networks, why do such large concentrations of particles arise so early in the universe? Why are they so important for what happens next, and what happens in the centers of galaxies when so many particles capable of intelligence are coming so compact together? If a counterforce stabilizes the masses and brings them to rest, what is at the centers of gravity of each galaxy? Why does each have one of them? And what does all this have to do with our embryo and the dividing cells? There is a parallel to the black hole. We have a photograph which clearly shows a black hole, and we can even observe how the cells divide and differentiate under the microscope. But what does it prove? As long as we only know about the DNA as a store for the genetic material, we, as analytically thinking scientists, must assume that in some mysterious way nature has managed to store all information about the division process and to run it in a complex program after an initial spark. Everything in the cell knows how to handle the DNA, what has to be provided, how to read the code and start the production. It is a small factory that produces something almost supernatural. Where in the cell does the liveliness begin, and what are just inanimate objects? Are the amino acids already alive, or is it just the DNA? How is all this regulated without central control? If substances are needed, who knows about it and who tells the cell wall whom or what to let in? On the one hand, everything should be chemical, just one object. On the other hand, there is such a finely tuned interaction of the substances that we doubt whether it can function so easily by itself. We actually see something living under the microscope, something that does not behave like an object. We marvel and wonder, but do not question it any further. We see the living but do not recognize what makes it alive. As long as chemistry or physics treats matter as objects, biology or medicine will not question life any further. Doctors see the same living things as chemists and physicists, for whom these materials are lifeless. Is life then only in the emergence? Does emergence bring the life? Can dead matter in its complexity suddenly be much more? Can it be something that goes against entropy and creates multiplicity and unpredictability? Again and again we encounter concepts and gap fillers behind which our ignorance is veiled: the Big Bang, dark matter, the event horizon, or even emergence. Nerve cells alone are nothing, but in the brain as a whole they are supposed to generate the mind, intelligence and our consciousness. It should be able to store feelings, images, language, knowledge, music and much more, and to do so organically, i.e. not identically one-to-one as in the computer, but depending on how emotionally charged the thing to be stored is. The memory can be stuck in deep tracks forever or be fleeting like a moment. Of course not a single cell can do this, but can many? Suddenly everything should be possible, just because there are now billions of them, which are sensibly linked together as a network in the central brain, and not just a few. The reason, or rather the secret, lies in emergence. Alone a cell is nothing, but as a network it is everything and suddenly creates something extraordinary, for example something wonderful like a self-sufficient mind. The many is more than its parts. If we have ordered 100 billion nerve cells in a structured way, then the mind emerges. Or not. We have never questioned it, because it is the logical consequence if atoms are soulless. We see the cells dividing, we feel the spirit within us, and we know that in the brain we only find nerve cells, so the solution must be emergence. Emergence. One nerve cell does not create anything, but a sufficient number can achieve everything, can think everything. This is how the analysis works. Physicists have consciously locked out life here, as if they were afraid of it. Physicists can handle numbers, and numbers are not only abstractly empty and fortunately without meaning, but they are also dead, have absolutely nothing to do with life. They are then safe from surprises. Something that is almost raised to a dogma in physics is beauty, but not the beauty of flowers or a landscape, but the beauty of formulas and theories. Sabine Hossenfelder has investigated this and found out in many interviews for her book that physicists usually think of beauty as 3 kinds of beauty. Firstly, there is the simple, for example symmetries or unifications, which make a theory more beautiful. 1 primal force is more beautiful than 4 because it is simpler. Then there is the naturalness, i.e. nothing falling out unnatural, unexpected, which is usually also connected with the improbable. If numerical values of measurements fit more or less well to each other, then they like to speak of a natural beauty. The third is elegance. Physicists like to use the term elegance for particularly beautiful theories, if it combines as many things as possible elegantly and still produces the unexpected, as is the case with the theory of relativity, for example. General relativity could not only explain gravity more elegantly and comprehensively, it also had surprising features such as black holes and gravitational waves. But how can we trust people who are in love with the beauty of formulas and hate the chaos of life? How can a person who has been bent by mathematics to abstract thinking in decades of study be freed from logic and the beautifully ordered arithmetic? Our society is full of specialists. They are experts in their field, masters in their domain. Nobody can hold a candle to them. That is why they will not be talked into it by anyone. They sit firmly on their small but highly specialized knowledge. Moreover, this knowledge has often been proven by experiments, and within their limited field they are also right. There are usually no mistakes. No wonder if they are the ones who are not open to suggestions from others in foreign fields. Instead, they enjoy their exclusivity and rest on their past laurels. Just as they don't want to be criticized, they don't dare to interfere in other areas of expertise. They may spend their time writing articles on their field of expertise, and they may become increasingly tunnel visionary. We probably have far too much trust in their knowledge and competence, or we ourselves are so moved by what humans have already discovered that there is a feedback between society and science that no longer allows for any freedom. We have all become prisoners of our own worldviews, and any doubt is only interpreted as weakness. The times of wild speculative searching have been replaced by endless highly specialized factual knowledge, although much is just lying there incoherently. Either one believes in modern science, or one is stamped and finds oneself with the spinners, with the conspiracists, the do-gooders or esoterics. Not only was the first photo of a black hole taken in 2019, but the very next year the Nobel Prize in Physics was awarded to 2 men and 1 woman for the discovery and calculation of the black hole. Any criticism of the existence of black holes borders more and more on suicide, if one wants to be recognized as a physicist and taken seriously. Yet many things could be so simple. Why not make the transition to the living much smoother, and why shouldn't there be central intelligences that consist only of atoms, are not organic, and still help shape the processes on Earth? Our whole dilemma, this disorder and diversity, the spontaneous and fuzzy and even life could be demystified, if the original building blocks could do so much more and were more comparable with life than with numbers. In life, we always need knowledge first, followed by implementation. Conversely, it would really only be a sluggish splash, a beautiful but unimportant flow. Let the universe grow and not explode. Let the particles come into being one after the other, and not suddenly out of the nothingness, suddenly all of them are there. Let us give them the ability to communicate and to store. Let them retain their identity, each and every one of them. The world has to be slow and inert and at the same time, and spaceless, and then we leave the whole thing to itself, with such interesting particles. What would happen? We know the answer, we see the result, because here on Earth it is openly presented and has become imaginable. Living particles create life, always and everywhere where it is possible. The mysterious, the magic only came with the mathematical approach. Thinking in numbers, the abstraction, the expansion of logic and axiomatic geometry brought the tool-loving hominid an intoxicating technique. And now, for the first time in the long history of the Earth, nature could not only be calculated, not only could predictions be made which then came true, but with modern man and his superior technology we gained control over more and more areas of nature. Handling, knowledge of materials, and above all digitalization changed everything. We are no longer helplessly at the mercy of our environment. We can now and have already changed the Earth and life on it in a sustainable way, not least because we have succeeded in virtually outsourcing ever more complicated simulations and calculations on the PC. What a power we as mankind have gained, almost something like a divine omnipotence. Despite its size, we small beings on Earth make lasting changes that affect the entire ecosystem. At night you can see the many lights of cities and conurbations from space. Why should we doubt the physical mathematical approach? Just because life does not fit the theories? Technology and mathematics take us forward, they give us power and control. What does it matter if you don't know exactly how life came into being? And yet, even if the solution would not affect our everyday life, we should look for the answer. And if there really is another, better approach, we must take it, because life, the human brain with its way of thinking, is still far superior to machines. There are still worlds between a robot and an animal. The way an animal, a plant, or we humans are created, the way our body is repaired and nourished, the way we move, play the piano or climb mountains, all this is incomparable, and something that creates something like this and simply continues to do so and keeps it alive for hundreds of millions of years will certainly hold surprises for us. The secret behind all this could be important for us, maybe even vital for our survival. Foreign networks, other intelligences. Do we really want to continue to believe in our old, reliable miracle stories about the origin of life, or do we not want to go further and see what new things are opening up? After all, if our story is true, the universe should be full of intelligences that have perhaps been waiting for a long time for science to discover this too. Because if almost everything is alive or intelligent in its own way, then it must be possible to make contact with these networks even without intuition, entirely through technology. No spaceships that come to us and are filled with aliens, and no extraterrestrial signals from other worlds. That does not get us any further, for that the distances are simply too great and other worlds too alien. These ideas belong to the mathematical universe, and in that we are too far away from everything with our solar system, the dimensions are too big for us, but there is also a second space, and timeless world, namely that of transmission. Everything that is transmitted at the speed of light is space, and timeless for the exchange particle. There is no in-between and no sequence for the electromagnetic quantum, but there is also no sequence for the essence of gravity. There is always only the beginning and the end. And also from our view of the world it is never possible to observe a single particle on its way to its destination. Either we know where it is, but then it has already arrived, the measurement was then the target, or we know where the beginning is, send out a lot of exchange particles and intercept a pair of them on their way, then one could think that the particles that are not intercepted are also on this path at a certain point in time, only, that is not how it works. For the quanta that were intercepted, the target was never the same as for the particles that were not intercepted. This is true even if we move something into the orbit after the emission, i.e. change the conditions on the way. The quantum always knows where it is going to arrive and does so before it jumps, not just before it reaches its target. There is something very irritating about this contradiction, this simultaneity of two such contradictory views. We cannot believe it and refuse to get involved. The mathematical logic must be right, always and everywhere, and after that a quantum cannot simply jump so space and timelessly when beginning and goal are far apart. We like to celebrate the proofs and successes of relativity theory again and again, award many Nobel Prizes for research on black holes, but when we encounter the simplest and most obvious consequence of the theory, we ignore the ambivalence of the results. Time can pass more slowly, even for us humans, if we move fast enough. But the fact that time does not pass at all for electromagnetic waves and gravity is simply ignored. That there are then two views, also with gravity and not only with wave-particle dualism, we deliberately overlook. But if the electron knows where the target of the quantum that it is about to emit is, we can also take the approach that these two electrons, the one from the beginning and the one from the target, are one for a moment. Not just any quantum is sent out, but the two particles themselves are together for a tiny moment without space and time, before they are again both at the starting point. Back, but with a small amount of energy and momentum information in their luggage, which leads to a small change in motion for both of them, almost exactly according to the momentum and conservation laws of physics, but only almost. Because energy and conservation of momentum do not function like mathematical numbers, they are not arithmetical values. If two particles lie on top of each other, then it is not two numerical values, but two memories that are suddenly compared as a whole picture, as one pattern, and both patterns are not the same. Each particle has its own memory, its own connections to other particles stored, so not a 0 or 1 is read out, but a matrix or even a tensor. This tensor, like an energy impulse tensor, changes the further movement of the particle when it has jumped back again. For this we do not need a small atomic ball, as punctiform as possible, as the quantum theorists wish, but we need particles with a complex structure. If possible, they should consist of two levels, which represent a memory that only has something to do with this one particle. Even the particles themselves are probably highly complex. They have a memory that slowly fills over billions of years and stores everything we experience, and we have process times that exceed our best computers. Such particles could be used to build quantum computers for which, in our view, there are no limits. In quantum computers we have to laboriously detach the qubits from the environment in order to be able to calculate extremely computationally complex calculations in parallel and almost timelessly in the short contactless time. For particles, there is no need for an interface to the macroscopic world as in quantum computers. Particles always work only in their own world and can constantly process vast amounts of data in parallel and extremely quickly. If particles are arranged in the same way as in our universe, then it is possible that it is teeming with larger and smaller quantum computers that run incessantly and calculate permanently. Of course, it are not calculations in our sense. It would probably be better to write they are permanently thinking. But then we feel immediately what can be meant by the fact that there is strange thinking that we cannot decipher. If networks have been thinking for billions of years at the speed of a quantum computer, what has been thought and how can we even imagine such a thing? We love stories, everyone loves them, can't get enough of them. Probably even prehistoric people, as soon as they had words, told each other their hunting adventures in figurative language, descriptive, strongly exaggerated and as scary as possible. It is not the formulas that fascinate us, but the secrets they tell us about the world, the stories that arise from them and stimulate our imagination. Sober scientists are just as susceptible to this as filmmakers or book authors. Stephen Hawking has not only written abstract treatises on the evaporation of black holes and much more, but also science fiction adventures for children. Often it is even the book authors with their overflowing imagination who help science to find new ideas. One of them is the idea of the multiverse theory, which is inspiring more and more scientists, and some even support it with the corresponding mathematics. According to this theory, there are endless other universes besides our own, which exist parallel to ours. That there could be countless other worlds besides our world is not a problem, but it only becomes tricky when we want to travel or cross over from one world to another. Then we realize again that there is a difference between our thinking and reality. While it is easy for our mind to imagine that we could travel from one world to another with a magic object, a knife that cuts through the atoms themselves, reality looks much more sobering. The story behind such many world theories is of course breathtaking and would turn our seemingly empty and boring universe into something grandiose again. Everything is then imaginable again. One wonders why we want to live forever, when after only a few decades here on Earth we find everything just ordinary and commonplace. More and more we want to be taken off by machines, by robots and artificial intelligence, but what remains for us to do in the end? We have to let the fabulous, the unimaginable, but realistic, actual things get to us again, and we have to do it emotionally. If life here on Earth in its complexity shows us what the universe is capable of, and that this is not the culmination for us, but that behind it there are other much more developed and hardly comprehensible intelligences, then we do not have something like the key to the parallel universes, but an universe as enormous as ours with this dynamic and now perhaps filled with tens of intelligences opens up just as many possibilities to get to know completely new worlds, at least as a story. This is especially true if it should be possible to overcome any distance timelessly in thought. The potential is there, we only have to break away from the old corset of ideas and concentrate our thoughts on the new many worlds intelligences. If these networks exist and we compare ourselves with them, we are hopelessly inferior to them. If we let ourselves be impressed by supercomputers and quantum computers and take them as a benchmark, then we have already lost. For example, computers are now so fast that a chess computer would easily win against a chess world champion. But that is not the benchmark. It is not the speed and not the memory capacity that makes us human. We are the sluggish, the pensive, the thoughtful, the calm view of the whole and the one that releases such great feelings of joy and suffering, lust and horror, multiplicity and unity, love and death. We can suffer, we can fall in love, but also hate terribly. We can do so much for which logic and speed are not important. We can do what such fast particle networks cannot do. And yet there must be something like a symbiosis. Probably we would not live for a second without this second intelligence in the background organizing and directing everything. We think and feel too complex and different from these networks for that. We develop fantasies with a lightness of touch and in a way that such alien intelligences might not be able to. Moreover, only we can form and change this inert matter, this stubborn, dull, large, physically real matter against entropy at a speed that is incomprehensible to spiritual beings. We bend huge steel beams and use them to build bridges from one country or in some places from one continent to another. We release energy and give direction, and only a few forces of nature seem to be indomitable to us. That which is our curse is also our strength. Sometimes we destroy everything in violent, ugly wars and then we rebuild it more beautiful and bigger. The Earth is threatened by our climate collapse, but only we, together with the intelligence of the networks, can still save this our only possible world. What are our pillars? But before we speculate about how we can cooperate with the intelligences and what awaits us there, let us perhaps summarize the most important pillars of our universe structure. After all, there is a lot at stake, because hardly anything of the generally accepted standard model has existence. We are not questioning the great mathematical equations that result from the experiments, we are only interpreting the results differently, in accordance with the observations and the basic formulas. We do not doubt, for example, that the energy of a particle can be calculated from its mass via E equals mc squared, but we give a picture of how this can also be imagined with two planes. Not the old idea of a sphere on which the charge sits, whose electric surface charge determines the radius and whose size corresponds to an energy value that is in line with the mass of the electron via the formula above. The idea of the sphere is too banal. Globes are mathematically beautiful because they are simple elements, but they are curved and that continuously, i.e. infinitely variable, which does not fit the quantum world at all. They are also directionless. Only when it rotates there is an angular momentum that has an orientation and is comparable to a spin, if it is considered as not continuous. In quantum mechanics, this continuous spin is then quantized, its rotation is only gradual, but the surface of the ball is then still directionless. The continuous apparently has nothing to lose in the micro range. In addition, electrons transfer the quanta, which are not spherical either, but have a plane waveform according to the calculations, so why not take two planes instead of one sphere, which are opposite each other at a fixed distance and on the one hand define the microstructure of space and on the other hand determine the size of the mass or the amount of energy with their distance. Space is defined because henceforth only particles will see each other if they are many times the distance between them at the appropriate distance of the planes. The microstructure is flat or Euclidean, and the two planes are charged, have a voltage, and are in equilibrium with all other particles within the universe shell. Furthermore, the two planes cannot slip away to the side. The particles show the smallest space structure. This is how it looks like. The universe as a whole obeys the field equations of general relativity, with the difference that in accordance with the equations, the universe grows in stages. Newly added particles are planes that are created at the edge. The edge of the universe moves at the speed of light, and there is always so much ordered mass in the universe that the Schwarzschild condition is exactly fulfilled at the edge. Without wanting to go into the details again, for particles are always created if the gap at the edge is large enough. An electron and a positron, which are created with the basic distance between the planes and determine the step size of space, and a proton and an antiproton, which have an ever-increasing distance between the planes in accordance with the size of the universe. Antiproton and positron move away with the edge of the universe, proton and electron remain at rest. For this approach to be consistent with the theory of relativity and the Schwarzschild conditions, the mass of the proton must change linearly with the radius. Further outwards, the protons are lighter than further inwards. This limitation is serious and fundamental, because physicists dream that both the fundamental constants and the elementary particles are the same everywhere in the universe. In other words, the mathematical law, indeed mathematics itself, is an overtheory and applies not only in its abstract logic to this universe, but preferably to all universes that have ever been created and come into being. For this, the proton mass does not necessarily have to be the same everywhere in space, but it would shake the claim to absoluteness severely if the protons were to behave as not quite so mathematical. If the proton mass of distant galaxies is different from ours, it would be very difficult to prove, because we only learn about distant atoms through the electromagnetic spectrum, and this is created by the electrons. Nuclei only play a minor role in this. What we observe very clearly, however, is this spatial expansion already mentioned. Here we make the second big cut and interpret it not as expansion of space but as expansion of time. Just as if we were inside a black hole, time slows down towards the edge and stops exactly at the edge itself. It does not pass there at all. However, we now have the opportunity to describe this mysterious time dilation in a completely different way. We see time as process time, or as how often particles exchange their information between themselves. New particles at the edge do not exchange themselves at all, so the process time is still zero, or the course of things like infinitely slow. If the edge moves away, the particles make contact with each other. Again, we don't want to go into details. With each contact the process time runs faster and faster, because there is an exchange to more and more particles per second. This is where decoupling from infinity comes into play. The exchange between two particles is still time and spaceless. When they have contact, it goes with the speed of light, from which we draw the conclusion that the particles lie on top of each other for a short time. With the distance to the edge and time, the number of contacts increases, the matter becomes slower and slower, more and more inert. This can be seen in the uncertainty of the electrons, which becomes smaller and smaller. This means light from hydrogen atoms produced in the distance is longer wave, because the uncertainty is greater or time is stretched. Here on Earth we get redshifted radiation, which is linearly more and more redshifted with the distance of the galaxies. But it is time that stretches, not space. The overall picture also includes the fact that matter moves away from the place of origin with increasing interconnectedness, that our picture depends on the other galaxies, but on the age of the atoms. According to this, we belong to the inner circle of the center of the universe, but we have clearly moved away from it. Only, we are almost the oldest matter, and all other matter is then less blurred or less inert, i.e. less redshifted than almost everything around us. The further away the more redshifted. This all works very well with the formulas and equations and fits the observations. A few small but decisive changes such as time instead of space expansion, a process time that is something real and not a mysterious universe time that is only derived from physics, and a matter that is not everywhere equally inert. This universe can still be mathematical, but in a more closed structure. But surprisingly, the approach with the particles as two opposing planes and the fact that energy or mass is involved, and of course the fact that there is life, which also has to be captured, quite unexpectedly results in a new approach that changes everything and was not intended to do so. The levels can shift, that is, they can absorb and release energy. They also have a direction and do not go in contact with everyone and everything. Thirdly, they have a layer thickness, which also determines the level shift. If you want to determine this step size for a whole universe that lasts 1,000 billions of years, you get a plane thickness and a portion of energy for each exchange, which is tiny. These numbers are still mathematical values and fit logically into the structure. Only, now one can also interpret this shift of the planes, or the exchange of matter between two particles that have contact as storage. Figuratively as two wafer-thin planes of the foreign particle, which lie behind the main plane. We don't have to see it that way. You can also just let the main planes shift and keep your mathematical universe, but then you have no possibility to understand the complexity of life. Here at the levels you can put the lever and collect many small foreign levels and thus have a memory block, which in connection with process time, exchange or communication has the potential to form networks. But also the process time or communication is not intended by the physicists. One hardly believes it because it seems so conclusive, but quantum mechanics does not provide for permanent communication in its interpretation of nature. For them, particles are free and independent as long as they are not observed or in contact. A quantum mechanical particle is a free, divine particle within its uncertainty, which is not controlled by the laws of classical mechanics or the fields. However, this only results from the Copenhagen interpretation of particle nature. Quantum mechanics proves to be great for calculating chaotic, possibly thinking systems, but we don't want to calculate everything. We also want to understand life and the world, and then we have to say that the particles are not free within the blur, but the networking and inertia creates the size of the blur. The number of times the particles exchange each other determines the average distance a particle travels. At each contact the particle changes its direction and its speed. The particles then move towards each other. Here there is a difference again. Electrical contacts try to aim at the same particle when they have opposite charges. Gravity, on the other hand, is not fixed, and it will make contact with everyone it has already made contact with. If the electrical connections are aimed at the close range, gravity stands for the far range. Charges create stability. With them you can build worlds, the most diverse constructions, which then last for long periods of time. Big and small, they are the building blocks from which everything here on Earth is built. But they are stupid. They do not know what they are doing. They form lattice connections, just as we know it from the mathematical universe, but they are not thinking networks. Thinking is about gravity. The electrical connections are not memorized, nothing is stored. Here everything behaves originally as quantum mechanics and electrodynamics predict. Why should two charges remember their exchange, when most of the time it is always the same pair of charges that exchanges? Charges are the basis of the mathematical universe, and because they always aim at the same pair, they are incomparably stronger than gravity and seem to be observable. We also cannot see the individual impulse exchange, which lasts 10 to minus 18 s, and is just as light or almost as energyless as gravity. The gravitational connection, the contact to the many, is captured by Einstein's field equations. Masses have so many jumping connections to the most different other masses, sometimes near, sometimes far, that they can be described very well as fields. In addition, there is a sophisticated mathematical theory about fields in general, so that they fit together perfectly. Only, as already mentioned several times, the fields of mathematics can be regarded as homogeneous and infinitely fine in an idealized way. In reality, on the other hand, at some point in time we encounter the individual exchange with the individual communicative contact, which is not only concerned with the conservation of impulses and energy, but is part of a thinking network and becomes increasingly individual and complex over time. If we could observe gravity, then the movements of the particles that result from it would not remind us of a gas, but of living structures. Gravity makes matter alive. It knows what it wants and none of its movements are purely accidental. Only it is so weak in comparison to the charges that we cannot follow it in single particles. It is like in human thinking, which wants to weigh a thought. How much energy does it have? How do you want to move a boulder to the pyramid with billions of thoughts? Thoughts are too light, they cannot do anything, and yet without them there is no mighty structure. As light as gravity is, as little the thought itself moves anything in it. It can transform the laws of conservation and cause inert matter to move according to its ideas. Ideas and thoughts know no entropy. They do not look for the ordinary and simple. They want to try everything. They want to try out everything, bubbling over with ideas and images that do not immediately disintegrate again. Thought or intelligence is not physical. Thoughts themselves need not pay attention to energy and impulse conservation. They do not form themselves in such a way that only the lowest energy state adjusts itself. Their possibilities are in principle unlimited. Nevertheless, they are bound to matter. If the ashlar block is to be moved, we must do it with the means of the inert heavy world. We have to lever it with large rods and place rollers underneath it, so that it can then be moved on slowly with a lot of force and energy. The networks must do something similar with matter. They must also make the heavy protons and atoms move in a certain direction. Thoughts cannot do that themselves, but in agreement, many particles can move in the wrong direction, so that a few special ones can move where they are supposed to. Thoughts need the many and they need the open to control things a little bit. They simply hurl vast amounts of material out into space and then get small ordered structures according to their will. So they can cancel out entropy and then create orderly structures. How to avoid emergence? The beginning is still relatively simple. At the beginning it is more or less only about the fact that thinking comes into being at all, that as many particles as possible network together, which is not very difficult to achieve. The particles are designed in such a way that triggered by a trigger particle, orderly movement comes into the world of ordered contactless particles. Like an avalanche, the particles network among themselves, and since the speeds of such almost inertia-free initial particles are still close to the speed of light, vast numbers of them can all be set into wild motion by a single trigger particle. These movements gather around the first particles. They form the nucleus for the later galaxies. The speed of light creates very large networks, but they are not endlessly large. Nevertheless, the particles that belong to these networks are sometimes very far apart. If the particles were just a gas, a hydrogen gas mixed with some helium, nothing would happen over time. Whether or not they are cross-linked in any way is irrelevant. If you throw grains of rice on the table, you can wait a long time for them to turn into a rice cake. Time will pass and the rice will just keep lying around. Even having a lot of time is no help. On the contrary, at some point the house collapses, the earth is almost swallowed by the sun in the distant future, and then in the end everything is gone, without such a stupid rice cake ever having formed. Not in this universe and not in all the other parallel universes that might still exist. But the particles in our Primeval galaxy cloud are not only networked, but there is a rumbling in them. Here time is working for us. With every exchange, every readout of the memory, an increasingly complex knowledge of the whole slowly emerges. With the overview also the understanding grows, which the parts must come closer for a uniform total thinking. Then the connections could run faster and reach further. The individual parts, this piecework, could then grow together into a whole. Moreover, such a concentration is easy to achieve without much effort. Only the connections to the other networks, from a certain distance, must be cut. If a network decides up to where it wants to have its parts still with it and from when it sees them as strangers, then we have a limit and everything else follows by itself. As soon as the border is fixed, the cloud is closed and starts to contract more and more, to concentrate the matter. The density of matter increases more and more, but also the density of excitation, and that was the purpose of the action. The networks become faster and faster at the same size, and more matter accumulate in the core area, where the communication increases exorbitantly. In principle, superfast quantum computers of gigantic size can now also develop here. The mass concentrations in the cores of protogalaxies are close to those of black holes, but do not reach them. Particles still need contact with the antiparticle at the edge to ensure the unity of the universe, and they feel a force coming from their original position, which becomes stronger and stronger as the concentration increases. In the protogalaxies there are huge masses at the center, but they are not only obtusely attractive, but perhaps even structured in their arrangement and interconnected as thinking networks. The larger such quasi-black holes are, the less aggressive they are. Stellar almost black holes generate such strong gravitational fields that other extended masses are torn apart by the tides even at some distance. This means that the side facing the mass concentration is attracted much more strongly than the side facing away, because the mass attraction increases with 1r², i.e. the inverse square of the distance. This looks quite different for galactic supposed black holes. If there are masses of the order of millions to billions of solar masses in the centers, the forces occurring in its vicinity are comparable to our gravitational pull or acceleration due to gravity. Nevertheless, newly added matter does not simply fall into the area of the black hole, but is first crushed on the accretion disk at extremely high speeds. In the process, it emits X-rays and gamma rays, but also a lot of radiation in the visible range, which we can then observe. Matter loses energy and slows down until it is adapted to the pseudo-black hole and silently merges with the concentration of matter. Presumably the protons and electrons are no longer separate here, but the protons are again embedded in the electrons and neutrons are created. Then these areas are electrically neutral, held together by gravity, which is no longer Newtonian. It can be that these mass accumulations are forced to keep in order. The particles probably do not move like a gas according to the Boltzmann distribution purely randomly and rather chaotically. Rather they are ordered as in crystals as a block, in which only gravity, i.e. thinking, determines everything, but which still has its gravitational and thus communicative contacts with the rest of the world. Something spiritual, where all chaotically moved matter has come to rest, a spiritual being. Perhaps they are without humor, without feeling, just unfeeling intelligent. But regardless of whether they have feelings or not, such gigantic networks, such super quantum computers can calculate, simulate, play through or test a great deal of possibilities over time. Only a computer of such dimensions can beat the game of probabilities. If we leave the particles in the mathematical universe to the mathematical universe, then somewhere, at some point, there will be an interesting coincidence that is preserved long enough and raises the level of complexity of matter somewhat. The probabilities for this are tiny and therefore rare even with the size of our universe. In our structure, however, we now have a think tank that knows a lot about the positions of the particles and can make a huge number of calculations in an extremely short time. Such think tanks will then not only be able to run countless simulations over the years, but will also observe what comes out of them over time. They will look at it and change the inputs, everything virtually, without having moved the matter at all and therefore at a crazy speed. But the most important thing is that at some point they look at the results in a meaningful way. Because then they will also evaluate the result, and that is the beginning of everything. If they have found something in their countless designs that is feasible and promises something more exciting than humorless monotony, then they will consider it to be good and set about implementing it. They change the spirit of the particles. They make contact, communicate until the inert matter with all its small knowledge stores has understood it and the ascent to a higher order can begin. It may be that because of the entropy billions of particles of a sun simply have to be hurled senselessly into space, because it cannot be done otherwise with the rough physical laws. A star the size of our sun must radiate billions of years and in doing so simply hurl material and energy into space. Then, on a planet like our Earth, with many other important conditions, water can be liquid for sufficiently long periods of time, in which, with further help, the atoms and molecules combine to form small living beings. But even here it would never suffice that all materials is present, that the conditions remain favorable for life long enough and that some luck is added. Even if in the Milieu experiment, in which the primeval atmosphere was artificially recreated, amino acids and other long-chain organic molecules were created after a short time. Life or the conditions for life seems so simple, so easy to create. In an inexplicable way molecules do what one should not expect from them. They combine and form larger and more complicated communities, as if it were easy, as if they enjoyed it. But with all this, nothing would happen if the world were the way physicists and mathematicians imagine it to be. Then something more complex would emerge again and again, but rarely, and it would not exist. Death and life. Dead animals, dead plants or people who are no longer alive cannot be brought back to life. After a stroke, other areas can take over the tasks of the dead cells, but the dead cells cannot come back to life. In a recently deceased person the cells are all in their place, everything is still there, but something makes the barely living body an object, where an insane complex order creates a sophisticated body, but which lacks something religious people would call the soul. Although everything is still there, life is suddenly missing, the higher context in it. So we could also throw all the ingredients of life into the primeval soup of the primeval earth, then constantly supply energy and yet nothing spectacular would happen. The substances would not initiate a gigantic life process out of themselves. It would not be the beginning of an unprecedented ascent, which would reach us after a good 4 billion years. No, nothing would happen at all. Dead objects remain dead. You cannot bring dead living beings back to life, nor can molecules or simple more complex compounds. Not in our mathematical universe. Mathematicians are not interested in life, and neither are physicists. Nevertheless, we have great respect for them, for their legitimate achievements and for their brilliant minds, and that is why we never noticed that a crucial ingredient was always missing. Religious people, or spiritual people in general, have never been interested in this. They do not deal with formulas and equations, so they do not make any impression on scientists. Without evidence, you can say anything, and even with evidence, people tend to bend reality to their ideas. Spiritual people do not need proofs. They feel life. They feel that there is something special. They believe in a divinity of creation. Such a creator need not be questioned. Non-religious people are more interested in nature. With the term evolution, everything is explained. But therein lies the mistake. We can explain everything because we can observe and analyze almost everything. We know the genes and we change them. We find out which genetic material is responsible for what, and we think we have life in our hands. But to observe something and to have understood the process does not mean that we know everything, that we know how inanimate matter comes alive. For example, we still separate life and death. We distinguish between animate matter and dead matter, without transition. Either it is alive or not. When we draw this sharp dividing line, we have difficulty finding, describing and explaining the living. Where does it then come from? Actually, only either God or evolution remains. The many elements interacting together create something special, emergence. But if that is really the case, a network of dead molecules can create something special. Can we build a robot more and more elaborately and complexly, and suddenly something new, something holistic comes to life from the many? Can mathematical particles ever be more than their constituent parts? With numbers, we would clearly say, no. With artificial intelligence we would not be so sure. The confusion lies in the fact that we experience it every day, that in our everyday world emergences of the second kind constantly occur. Our environment seems to be full of emergences. Animals, plants or humans emerge from a germ. We give the germ a few inanimate substances, some water, and out come living highly complex creatures. Our brain consists only of nerve cells, but in interaction with each other, our mind results from this. It works in the small, with just a few objects, as well as in the large, with 100 billion cells. Something special always results from the many, doesn't it? The observation is correct, but the conclusion is wrong. We cannot postulate that the many is always more than its parts, just because it seems to be so with us. Perhaps the parts that make up the many must be much more than that, and that is decisive. We believe that numbers cannot come to life, but we pretend that our living world is made of numbers. If this is true, then the conclusion that the many is more than its parts would be correct. But then we have the problem of finding the transition that must exist. Where does the special suddenly appear? If the components are mathematically analytical dead objects, and the many that consists of these parts is extraordinarily special and alive, then we have created a puzzle, and a serious one at that. Something mysterious must have happened somewhere, which suddenly turns numbers that never come to life, no matter how complex they are or how many of them there are, into a human being. The logical conclusion must actually be the opposite. The particles must already be more than just numbers, if man is made of them. Everything else would be a hidden veiling of our ignorance. Either particles are not inanimate objects, or we do not know how life is created. We would have no explanation and would only disguise the transition with a word like emergence. It is something different when we talk about networks that have formed in supposed black holes and generate thought processes like those in super-quantum computers. Here, it is not the inert matter that is complex in nature. On the contrary, in such black holes the particles are probably boringly lying one beside the other. No, thinking does not function physically, but rather in virtual connections. The storage of particles is different, the exchange is different, and the dimensions are completely different from what we know as storage. The kind of intelligence is probably mathematical, but the amount of possibilities and the size of the simulations that are possible are so incredibly numerous that what comes out and perhaps controls the particles is still mathematical in structure, but from our point of view the transitions here are blurred. Matter, if it is controlled by an intelligence, no longer behaves mathematically statistically, even if the intelligence behind it is strictly speaking mathematical. It is not our fear that we could only be a simulation that makes us differentiate between life and death, but we are rightly so impressed by what is created, we are so in awe of the sophisticated complexity of all living things that we feel we have to make this distinction. In principle, it does not matter whether we consider elementary particles to be alive, and it does not surprise us that we are also alive, or whether particles are mathematical, controlled by high-performance computers, and we are only mathematical structures. What is important is the intoxicating. As long as all living things are so versatile and unbelievably complicated in structure and still function, we don't care whether the intelligence behind them is great but mathematical. Nevertheless, we are not talking here about a mathematically designed universe, as the standard models of physics suggest. It is the level of complexity which serves as a basis. Is it the particles, which are our smallest building blocks of mathematics, with the help of which we can build up a complexity that will eventually build computers and quantum computers? Are the particles the numbers and is calculated in our computers and brains, or are the connections between the particles, every single exchange the numbers, and that which results from the networks of the particles by itself is then the complexity, and an emergence of first kind? That makes the decisive difference. Here you can find what we call life, this flood of knowledge and lightness, and how entropy is confronted. With the emergence of the first kind, the particles discover themselves as a unit. They network themselves out of themselves, which is not yet impressive and at first has nothing extraordinary about it. Many things, even in our inanimate world, can become more and more knotted, but also more and more chaotic, but that is where the difference suddenly begins. Particles do not become more chaotic but permanently form order structures, and they have a memory. Originally the particles did not know anything about each other. They originated at a fixed position in space with a certain distance between levels. Over time they made contact with more and more distant particles through impacts, but never confused and random, but rather with a connection to particles that exchanged and left something behind with the other. It is more a knowing each other now. They now know where others sit, they can be distinguished, because each particle carries different information. In addition, the contacts are refreshed from time to time. If now the connections increase with time, then the system does not become more and more unstable with a tendency to chaos, but it becomes more and more complex. The knowledge of the world is growing. Moreover, the numbers with which this happens are no longer imaginable for us. The number of contacts in 1 second in just one particle is now billions times billions, and yet chaos does not arise. The single particle thinks in billionths times billionths of a fraction of a second and still has stored every contact it has made in the many billions of years. The unit that carries all this within itself we call the proton. The movement it makes out of knowledge and the connection to others together then represents an emergence. However, the knowledge and the networking is already so structured that it is perhaps already more than an emergence of the first kind, like the temperature is. Also, the temperature is a value, which results from the many single movements of the gas particles, but it is nevertheless nothing special. On the other hand, our proton, as a summary of a complex structured knowledge embedded in an external network, is probably already much more than an emergence of the first kind. The next step is then what these many individual particles create together. Individually, each of them is much more than we imagine mathematical structures to be. Especially in connection with the boundless memory, we find it difficult to relate the whole thing to a number system, then rather with a computer. Nevertheless, we can still imagine that something like this arises out of itself and that what has developed from it over the years is extremely special. It is as if all kinds of programs were working automatically on a supercomputer and were constantly trying out new patterns in loops. It is difficult to decide whether at some point an evaluation of what has been found will begin, but, for all our amazement, we would still regard it as mathematical. But what about the networks that are built up from such highly efficient particles? What can they do? Is there an emergence here, and what kind of emergence is it? The particles need the net. Without it, the storage would be empty. Connected to the net, each of them becomes interesting and special. If there were a superordinate unit for closed networks as a whole, the individual particles would have to want it, it would have to happen from within them. For this they would have to develop a consciousness, they would have to recognize themselves, their position in space and their task. Then they could come to an agreement with others and together they could create a great consciousness, an emergence of the second kind. Not materially, but only spiritually, but in terms of the number of particles, what comes out of it would be at least intellectually equal to us. That it happened, that these intelligences must exist, we see in the universe, we see in ourselves or in life on Earth. But how it can be, what is there, still has something mystical about it. What do these special particles do all the time? Where and when does consciousness come into it? Can it have developed out of the inertial motion? There is something very amazing with this inertial motion of particle complexes as a block. For one thing, we know that matter can join together to form very large objects via the charges. In solids, the atoms in them are even extremely ordered, mostly in a crystal structure. The molecules or atoms that make up such a body are still moving. Every body has a certain amount of heat, but the area within the lattice is limited. Such an object can now set itself in motion. They can also be as big as rocks. A body composed of billions upon billions of particles, each of which feels infinity to the other atoms in the universe, because it continues to communicate at the speed of light through gravity and at the same time, as a block, makes a slow worldly finite movement in space. Up to now, everything was lightning fast for the individual particle and much was immediate. Now it is electrically connected to many such lone warriors in a tight corset and experiences something together with all other particles, the slow world of inertia, our world. It is a world, familiar to us with large bodies of matter, many resting in the reference system with manageably slow movements, in which time does not run in tiny fractions of a second, but is counted in seconds, hours and years. For particles, everything has so far been jumpy and incredibly fast. And suddenly, a body familiar to us manages to capture all this wild information with apparent ease and to turn it into a slow common inertial center of gravity movement. An emergence. It seems to be very easy, at least from our point of view. All individual particles seem to join together over billions of years in solids and create an inert motion that does not decay. And now comes the astonishing thing. Now there are two, if not three levels of the world for the particles, three ways in which they can experience the world. The first is the old familiar space and timeless world, where the particles still have contact with all the other particles via gravity and store this contact. It is a more virtual world of thoughts, enormously fast and not limited in its ideas by physical laws. There is no entropy, no distance in our sense of the word and an uninterrupted contact with other particles. Then they experience secondly a feeling of slowness, a space and a time that continuously pass by. They can only experience this feeling as a common body. They feel the physical laws, the inertia and have to fight constantly against a decaying order. And thirdly perhaps something that results from the large electrical arrangements, from the electrical grid connections that are not stored. But we do not know anything about this yet, although the electrical forces should be most familiar to us from the modern world. But whether they really produce something of their own when they are combined is still completely open. Continuity and the jumps of photons. Particles now experience an ambivalent reality that seems so contradictory to us. On the one hand, the world is limited by the speed of light. Nothing can move faster than light. For us on Earth, this limit speed is unattainably high and therefore everything in the universe is endlessly far away. For us, space must always be crossed slowly. We know no leaps in reality. Everything moves continuously fluidly. For us there was never any doubt about this world. It was always closed in on itself. The first break came with the theory of relativity, which incomprehensibly told us that space and time are only relative, and at the speed of light itself, even both no longer exist. When light is exchanged between atoms, we can imagine that a photon is sent off, moves through space at the speed of light and, depending on the distance, eventually reaches its destination. This is no longer possible. We can invent a photon, but it is not really in the space between the beginning and the end, but from the point of view of the emitting particles it is there immediately. For a very small moment in time, the initial particle sees the final particle. Particles have this experience, we do not and we cannot even imagine it. From our point of view, particles would be small time machines that see at the beginning what we can only see after the photon has passed through. Space and time lose their meaning for a quantum. A photon, which comes from a distant galaxy, knows at the beginning where it arrives after many millions of years, despite the vastness, otherwise it could not fly off. This means that the photon does not notice anything of all the many processes, of all that happened in the universe in between during the millions of years. It arrives at the end and the world has become older by millions of years. Particles know about the gravitation, which also takes place at the speed of light, always only about the one particle, the one with which it has contact, where it will be in the future from our point of view. But since particles have many contacts per second and everything is stored, they can probably get an idea of the positions of a great many particles and then obtain sections of the whole. But there is too much information with little order, and so they may be quite grateful when order is introduced into the diversity through the great connections of matter. Since there is so much that is beyond our imagination, we now assume, for the sake of simplicity, that through inertia in solids, from the diversity of information a single entity emerges, which is the emergence, and this is an emergence of the second kind. That is, that in this fusion the particles create something that is much more than their parts. Which is aware of itself, intelligent, has a consciousness and can evaluate things. Then we can assume that matter not only looks at the world around it, but that at some point it begins to influence it and slowly changes it according to its own ideas. If a photon knows where it will arrive in 1 or many millions of years, knows its end particle, then that is very scary. Then the consequence of this really explodes everything we can imagine, because then it means that everything is predetermined, that everything is connected with each other, and that some things can perhaps be calculated in the universe. We can't, but some big particle systems maybe can, or not. That we, as already mentioned with the mathematical universe, can in principle not care whether things can be calculated or not, if only the smallness, the complexity and the versatility of the world is only high enough or as impressive as it is with us. Nevertheless, such a fixed procedure is always something sobering, just like a mathematical life. For us it seems like a miracle if we move backwards in evolution, that the chain of generations goes back further and further in millions or billions of years without a gap, and that we all perhaps descend from a first unicellular organism or even lower. Yes, the whole universe was created from only one particle. Of course, you shouldn't look at evolution from behind, but there is a certain reverence in us that we are one of those who have seen it work seamlessly over such a long period of time, and that it then ultimately led to us. With our photon, the answer is not quite as impressive. We only have to see the world from the point of view of the photon. The photon knows only the one future particle, nothing else, or it knows when it connects to whom, maybe not even where it is then or by how much it has aged. It has not calculated the position, but it was together with this end particle at some point, and every contact is not only remembered, but also after a certain period of time is released again. The world of contacts is without space and time. Here it is who was with whom and when that counts. The space and timeless world is the older and the first structure. Our world is based on it, created by the many connections, inertia, space or time and slowness, but also complexity, decay and thus transience. The large complex structures are ordered in spite of the huge number of elements from which they are built, or at least order mechanisms appear again and again. This means that even for a single particle, the many contacts are not confused and chaotic, but as in social media, there is an order. Single particles do not keep contact to all particles of this universe. They only have to remember who they were with and who they have to contact again, no matter where he or she is at the moment. When we write to a friend on Facebook, the message goes out without us having to aim the phone anywhere, and the message does not get weaker and harder to identify the further the other person is at that moment. No one keeps track of where we are at the moment without a reason, yet we are permanently connected as long as the mobile phone is on. The message goes out and it is clear on the net where it has to go, and that without a map or that a signal is targeted and searched for. We don't know whether the website we are opening led through the Frankfurt node, or even whether the connection was forwarded via satellite, nor where the website operator is located. If the mobile phone is on, we cannot sneak out of the network. Space and time no longer play a special role given the size of the network. It is constantly being recorded. Even particles are permanently on. They can't just log off and reappear somewhere else. On the contrary, there is a permanent flood of exchange. Everyone observes everything and every change is registered. Inertia is the expression for this. If a particle wants to move, all connections have to be constantly re-established. Everything in the network changes, but apparently this works effortlessly, because our internet works in the same way. Nevertheless, the idea that particles make contact and the quantum knows where it arrives is eerie and very strange. Just as with mobile phones, the message arrives at the previously selected recipient. On the one hand, because the particle network is so insanely large and would be nothing but chaos for us, and on the other hand, because we can still seemingly insert a quantum between the beginning and the end. We could make the quantum world visible to us with many quanta and seemingly adapt it to our world, couldn't we? We have not seen a single quantum yet. And in fact they always behave most strangely when we think up experiments to look for them. Then it always shows how ambiguous all explanations are and how uncertainty the space and the movement in it becomes. We cannot observe the process of the exchange of two particles without gaps. We either see the particle that emits something, But then we do not know where something is sent to, and we do not see the photon as it separates from the particle. We always only know the probabilities for the events and their effects. From the point of view of the particle world, it is now becoming interesting because each particle can not only make contact, but if two particles have contact, they could also read the memory and thus gain virtual knowledge about the position of other particles in principle. But for this to happen, i.e. for us to be able to read the future indirectly, or at least to obtain information in the present in timeless space jumps, the particles would have to be very highly developed. Such a thing is not conceivable for the individual particle, but this could actually be the capability of the large mass accumulations in which there are perhaps units that can be compared with intelligence and consciousness. In these emergences of the second kind, an overview then develops from the many individual pieces of information, a knowledge of the structure of other worlds which are far away and yet can be observed in the present time. But then one must reckon with a speed and a parallel simultaneity, which we humans can never reach. If then still influence on the matter is to be taken, then we assume that ordered mass accumulations are necessary for it, which are of the order of magnitude of allegedly large black holes. Simultaneity and freedom. But then what about our freedom, the freedom of the mind, the freedom of the particles to choose between different paths? Is our world still free, if the quantum knows where it will be in many years and even has this knowledge at the start, or does not everything have to be predetermined always and forever? Can it even come to life if particle systems do not have the freedom to think what they want? If we seek freedom, we will probably not find it in our sluggish world. The mathematical universe is a humorless bureaucrat. Everything must be adhered to except for the icing on the cake. Everything that we measure, observe, analyze, track and predict is based on physics. The more precisely we search for or record the smallest thing, the more precisely it will mercilessly submit to dictation. But there are still many more freedoms, even in the quantum world, and physicists have long been aware of why they have resigned themselves to these areas. On the one hand, there is the volatile nature of particles, then phenomena such as entanglement or uncertainty, which physicists even interpret as giving the individual particle an intrinsic freedom. Inert particles adhere to the physical order, the more inert the stricter, but they also have a mind, belong to a network and have a memory. Here we immediately have the feeling that with the ease with which thoughts can be thought, the freedom sits. Particles or particle systems can think what they want. As long as they do not want to implement these thoughts, they are free or so incomprehensibly diverse and complex that it does not matter whether it happens like a program or a real abstract, i.e. disembodied creations. We do not have to decide that. But there must be an interface with reality. If they want to, they have to be able to exert influence, and we suspect that this happens exactly when nobody is watching and recording everything. If they want to change a blunt mechanical process, a photon or a graviton does not have to arrive as planned where it was intended. Maybe the quantum still knows in advance where it will arrive, but the plan has been changed. If all the impulses and energies of all the particles were extrapolated, another particle would have been on it. This now comes up empty. Such small misdemeanors in the conservation laws lie within the blur and cannot be measured by us. But, as small as the manipulation is, the more often it happens, the more serious the effects become. Slowly and very laboriously, entropy can then be circumvented and the world can continue to develop. But it only works if the sluggish world does not notice anything. If we were to take our measurements, we would immediately limit the possibilities again and nothing conspicuous would happen. This also applies to our brain. In the conscious state we see a solid, stable world that is always the same in its own way. If we close our eyes, we only follow the pictures, then we see the world much more vaguely and immediately we have the freedom to imagine everything. So it is extremely dangerous to close your eyes when driving a car, because we immediately start dreaming and forget reality. Driving a car, you immediately realize what deadly consequences this can have. We must constantly be in touch with reality. At school we can look out of the window and wander with our thoughts during a boring lesson. In the worst case we miss the teaching material, but are very creative again, because suddenly a lot of things come over us like a flood of images and thoughts in a very fast sequence and fascinate our ego. We can be very strict about the logic and absolute correctness of a proof, but we can also intuitively grasp something as correct. Proofs are usually very simple, yet difficult to follow, because we have to concentrate enormously on only one possible rational way. This rigor is difficult for us. With intuitions, on the other hand, we usually have to deal with complex and confusing guidelines. The many and complex interrelationships that somehow relate to each other, that are interwoven by a confused order, that want to be found and evaluated. For the proofs we do not need external networks, a calculator or a computer helps us more. With intuitive feelings, images and thoughts, they are certainly involved. Here the problem is grasped as a whole, as in seeing, and compared in a vague form with what is stored in us or in the networks. But only the reality of the image is real, the apparently stored image in us is not. We see something and think we know it, but as soon as we close our eyes it is gone. There is only a jumble of short images, emotions and a flood of thoughts within us, but we still feel the world, even our inner being, as constant and consistent. But only the world around us is constant in the present time. This present time is also the maximum possible time for particles to make their jumps. Distant photons do not jump into a future, but from one present time of the universe into another. When thinking sits in the centers of the galaxies and helps to steer us, it sees our images in real time. It is not the future that drives the photon, but the simultaneity of the present. From our world the quantum has to travel a long way before it arrives. So if the quantum knows in advance where it will be at the end, then it knows the future from our world view. But our world is also slow and inert, here time passes in processes that take place. Without knowing what is happening in the distance, there is still simultaneity. In the distant world something is happening at this moment, we only learn about it belatedly, because in our sluggish world the fastest information transfer is the speed of light, but only in our world. Things are happening now, everywhere in the universe, and there are apparently two ways to get the information about them. One is the familiar slowness of the speed of light with the resulting delay, so all information in the wide world is always out of date. And then on the other hand we have the world view of the individual particles, gravitons and photons. It is shaped by the present time, by simultaneity. It is not the future that photons see, even if it seems so contradictory to us. Photons only see something that is right now and is happening. As difficult as it is to imagine, but there are complex processes in our world and there are far away some, and only between these two can a simultaneity be established. The reality that is then seen in the distance is even manipulable. And just as two pictures of reality are captured in us, on the one hand, when we open our eyes, and on the other hand, the dream pictures in our world of thoughts when our eyes are closed, so there are also these two pictures in the world of particles. The view of the think tanks is the soft flood of thoughts and images that we dismiss as not really real, although only they manage to evaluate what we see in reality. Only it can do something with the static image in our eye and give us a feeling of familiarity or not. In the thought worlds of the networks, however, what we see as dream worlds is probably reality. The consciousness of the networks believes that their way of seeing things is the only correct one. The networks are oriented towards simultaneity and the present time. What is happening here on Earth now, although the intelligences for this are 27.000 light-years away? The information that arrives through our eyes, through our body, is only the secondary experience for them, exactly the opposite as for us. We do not take sleep and daydreams so seriously and concentrate on what we see, the near material reality. We like to watch films, but only if the familiar world is stored one-to-one. We are very firmly connected to our earth and our environment. The net consciousness, on the other hand, loves this lightness of thought worlds. This can be here and in the distance at the same time. It wants to understand and influence the physical processes of matter. It has a holistic experience that is not so much attached to a particular body. But there is probably a connection between the two consciousness, something very important, and we do not know what it is. There are many things we cannot do that the second consciousness can do, many things we do not even know exist that are possible. But in our limitation we have a very special world of experience. We experience the closed unity of a body, which can do what it wants with matter, despite all physical limitations. It obeys him, he has power over the laws and the heavy and inert matter. And apparently after a few years as a human being we cling to our life in a disturbing way, although we become heavier and slower and our creative lightness is swallowed up in us by consumer goods and knowledge with age. We want to live forever, although we have lost and forgotten the lightness of being that we had as children. What is it that is so important to us that we fear death so much? The intended movement. We know two types of movement. One is the aimlessly undirected movement of objects and bodies resulting from external conditions. When the wind blows through the reed stalks and each stalk makes its own back and forth movement. The wind itself simply results from the differences in heat and is not controlled, and although each stalk has its own individual movement, they too are only a game of chance. The other kind of movement is the consciously intended one. Here, life manages to steer against the prescribed random sequence of events and to achieve the consciously set goal. How does it do this? If we have a vehicle, for example a combustion engine, energy is released in the form of heat. For each cycle a small explosion is ignited in the cylinder, which drives a piston that transmits power and energy to the wheels via a shaft. Only one energy conversion still takes place. Thermal energy is converted into mechanical energy, or the kinetic energy released from the burning gas is cleverly converted into a rotary motion of a round solid. The rotation of the wheels is much more orderly than that of the hot gas, so it takes intelligence to build such an engine. But still the wheels just turn and would not bring the car to a certain destination. Nevertheless, in this machine, a worthless combustion, the lowest stage in the energy value creation process, is turned into a higher value common bundled mechanical energy. If we burn the petrol on the roof of the car, only the surrounding area is heated and not even for very long. If the petrol is burnt in the engine, a large heavy object can move many hundreds of kilometers away from its origin without destroying the car or leaving anything behind. A ton of car can then be taken to a completely different place, which is very valuable. A small tree weighing a ton or the many large and small plants cannot do this. Without a steering person, the place where it rolls would be left to chance, but with a little steering, a conscious mind can now determine with little energy what the goal of the movement should be. This all seems so banal, but is it really? Do we always have the freedom to reach any place, no matter what, and has it always been like that? We have already stressed that if we want to go in a certain direction, we have to leave something behind in the opposite direction. If we want to move forward, a counter impulse must be given via the wheels and the road surface. This impulse runs through the many atoms in the asphalt in exactly the opposite direction. The whole system of petrol, asphalt wheels and road plays along. The molecules during the combustion in the petrol gas mixture, all the ordered atoms in the piston of the cylinder, but also the wheels and the road surface, everything helps to get the ton of car moving, to keep the speed and to steer the car to where the driver wants it to go. If we drive 100 kilometers, many impulses run in the opposite direction over the whole distance. This is not a problem, because the asphalt is connected to the earth, which absorbs the impulses, and since the earth is very large compared to the car, we don't even notice it. With satellites or a space station, these impulse conservation sets are much more noticeable. Every movement has a consequence for the whole. But for all this to work, for us to be able to freely choose a certain direction from the many possible ones with our steering wheel, both in the car and in the space station, the combustion gases must also use all directions of space in the same way, purely randomly, in the case of a combustion. They have to move radially, then we can make a cylinder block move in only one direction and convert that into a rotational movement. On Earth, this principle seems to work all the time, and we can reach any place on Earth in this way. We can exchange goods, first trade, then spread knowledge and culture, and we can specialize more and more. Our freedom of movement is the most important condition for our dominion over nature. These directional movements create our freedom and are essential for the rise of intelligence. What about directional movement in space? Does the same principle apply here to rockets and spaceships? Can we reach every point in the galaxy with rotary movements? Can we also colonize and conquer the galaxy? No, of course not. On the one hand, the movements are much too slow compared to the distance in our lifetime, and on the other hand, we cannot repel each other by the road. To move forward in space, we have to fire something backwards at high speed. And if we want to slow down again at our destination, we have to fire something at high speed in the direction of movement, everything to maintain the momentum. Rockets also ignite a fire, make a controlled explosion, as it were in the cylinder of a car engine. But, in the car, we use oil as combustion material, which stored solar energy millions of years ago. It was formed on Earth, and the energy, the impulse and the car remain on Earth. In the closed system Earth, there is a transformation of impulse and energy and a movement that takes place on it. If, on the other hand, we want to leave the Earth and its sphere of influence completely, then we have to push the Earth a tiny bit towards the Sun. If we want to take a lot of fuel, water and food with us, and if the space station should be big enough, then we push the Earth a little bit more towards the Sun, because we repel ourselves on it. Or if we steer the spaceship towards the Sun and repel ourselves on it, then the countermotion of the Sun would be much smaller, because it is much more massive. If we had an ideal system, this inward motion would not stabilize again, but the Earth would continue to move in a very slow spiral motion towards the Sun. Admittedly, the dimensions are really infinitesimal and we do not need to worry about that. Nevertheless, the great distances and the associated question is whether there would be anybody who would sit in a spaceship that would leave the Earth forever with the prospect of not arriving where during his life. If so, then it would have to be families, where the great-grandchildren or great-great-grandchildren would perhaps land on a foreign planet, which might have favorable conditions for life. Something would have to be known about the destination, and it would have to be so tempting that people would sacrifice themselves for it. In general, we think very much only about ourselves. In a healthy form, we are little egoists. Of course, like the mother lion, we would give a lot for our children, but whether we would voluntarily sacrifice ourselves for our children just to make them feel better, this would have to be subject to special conditions. When it comes to climate change, we think more about whether it still affects us than about whether our great-great-grandchildren will find a world worth living in. Christopher Columbus had very specific ideas and reasons for risking the adventure into the unknown, and his chances of success were quite high. Sailing across an unknown sea, and in a completely new direction, is not at all comparable to visiting other habitable planets. On the one hand, because there is no return and one human life is not enough for that, but on the other hand we leave a place in this incredibly wide emptiness of space, which can't be compared with anything. It is an unimaginable wasteland out there, and not just for a week, but for many decades or centuries, depending on how fast the spaceship is. If it were as fast as 1/100th of the speed of light, it would take us 400 years to reach the neighboring Sunday. On their way to the moon, however, the rockets only reached speeds of a maximum of 11 kilometers per second, which is a 27,000 th of the speed of light, so the journey to the neighboring sun would take a good 100,000 years. And on the long way there is nothing. No oasis to rest in, no intermediate destination, just emptiness and darkness. But maybe there is a reason why we are so far away from everything. On the one hand, of course, so that we are protected from supernova explosions that are too close, but maybe we are not supposed to set off for alien planets. What for? Apart from the fact that we may not be able to drink the water there because it is too sterile or contaminated by foreign organisms, we always take it for granted that all the atoms and molecules from Earth take part. As will-less as the wind in the willows, as docile we believe that matter from the earth will help us to find and conquer a new world. But it is no longer so simple. When all particles are integrated in large and small networks, then suddenly everything has its meaning. Our freedom of will does not happen independently of inanimate matter, but only in harmony with it. At least if we want to use it for our purposes. Only as long as we give ourselves over to our dreams, we are completely free, but if we want to go to another place, this is only possible in harmony with matter, with its networks. Then suddenly it is not only an impulse that has to be kept or left behind, but then all connections, even the whole network has to be redesigned and rearranged. If we now intend to leave such a living, beautiful place like the Earth, then maybe there will be some people who would do that, who in their free imagination will think of something that makes sense to them, but then perhaps these thinking networks of inanimate matter will not agree with it at all. Maybe they are only indirectly resisting it, but we already know the feeling when things just don't work out, everything just goes wrong. If we really take an offshoot to another planetary system on another Earth and plant it there, then there is a network between the two planets, which cannot break off and which now always drags and pulls between the two worlds. If we really want to go that far out, leave our home country, then we should first of all manage to make contact with the think tanks, and then clarify with them where there is something to be found, and then find out what to expect there, whether we can really gain a foothold on a foreign planet. We don't make something this big out of just an idea. It should be clarified in advance in harmony with the whole matter. Otherwise such a mission would only be doomed to failure. And the spaceship would be on its way back again before it had even reached the outer planets, and this not only because the crew is consumed with homesickness, but also because all matter from the spaceship longs to return to Earth. We probably don't have the right idea of how complex we and our matter are connected with the Earth. It would probably be like trying to rip out our soul if we tried anyway. If it should be at all, we definitely need help, something that explains how to do it and why it is worth trying, but it is much more likely that we will be advised against it, and then we should not try it. Then we should accept our fate and not provoke it. Responsibility for the future. We may feel great and powerful within our human community, and the more we stare at what we have created, the more complacent we become. We do not need a god, no other gods than those of technology and consumption, and maybe we are also the beloved beings of the second intelligence and are under its protection, but maybe only humanity as a whole and not the individual. But for us, we ourselves are the most important thing. The feeling of meaning is attached to us as individuals, it is within us. It may be that people in other communities once sacrificed themselves for others, but this is increasingly difficult to imagine for people from industrialized countries today. People nearly hang on to their lives in panic. Even animals, even farm animals in cramped enclosures do so, but they have no chance of escaping their harsh fate of serving us. We, on the other hand, have the feeling that we have every right to do everything and owe nothing to anyone. We do not need to show humility or respect. The question is where we get our arrogance from, because we too are highly dependent on the fact that a huge number of particles, molecules, cells and organs are always functioning, that a connection to the other does not break off. The networks that we do not even come close to understanding and of which we do not even want to admit that they exist, and that they have such an influence that they protect us and regulate all processes within us. If they were to turn away from us, our lives would immediately come to an end. It may be that we are also important to the networks, perhaps even more important than we think, but perhaps not, and therefore we should not overdo it, because we are in any case mortal, at least our body. From the networks and their intelligence we can probably rather assume that they are immortal or last much longer. The Milky Way is very old. It is believed to be almost as old as the universe itself. Scientists also believe that even almost from the very beginning, in the centers of the galaxies, these enormous masses are concentrated in the smallest space, and that this type of black hole has existed since very early times. So it is likely that the matter in our Milky Way galaxy will also have collected and networked in its interior very early on. Matter is stuck in supposedly black holes for endless periods of time, so the intelligences in them will probably also live for as long as that, which is like immortality. In comparison, a human life is very short. However, new people have been born again and again since eternities. If you take the chain of generations as a long-time chain, then such a complete generational sequence is also already very extremely long. We pass on our genes incessantly. In addition, we humans pass on to future generations the wealth of knowledge we have gained through many media. Plants and animals cannot store knowledge, yet they too continue to develop and become more and more complex and multilayered. In the theory of evolution, it is only the genes that do all this, but we have serious doubts as to whether this alone is enough. We think that genes are only the physical answer to the intellectually abstract intelligence of networks. Thoughts need a material hold in this world. It must be stored in something physical, but the essence of information, the knowledge of how to do it, what makes the genes, the DNA come alive is the spirit of the second intelligence, something immortal. Seen in this way, the individual human being dies after a lifetime, but what he has experienced, the essence of his lifespan is not lost. It is certainly not stored one-to-one like a hard disk, but it is still there. When we dream, then we see many images running in us. Much of what we have experienced, but also things that we have not experienced, bubble up inside us. It is a kind of intermediate world. The individual dream phases are not too long. When we sleep, there are long phases where we are not dreaming, but also not awake. Phases in which we feel as if we are switched off, at least we don't know anything about it afterwards. Scientists rightly believe that important repair work is done during these phases, and it is better if our ego does not interfere. The memory contents are all read out and evaluated again, so they are important processes that we do not notice. We believe that during these sleep phases we are very close, very connected to the networks, that these phases are very significant and extremely important. It is probably not only about reading and reworking the memories. It would make much more sense that we would then be back with our mind in the nets behind, briefly recharging our batteries in the archaic structures and worlds. It is perhaps the state we take back to after our death. It is possible that we leave our body at night, but then we are not dead. Something happens to us when we sleep every night, only it is not the dreams, but something what we cannot remember, but what influences our waking state the next day. As long as we live, the spirit always finds its way back in time. When our body is dead, we only have the nets that belong to our body. It does not have to be a bad state, maybe we love the lightness of being without the heavy matter. After all, we need our dose of it every day. Babies are almost more in the foreign spiritual world than awake on earth, and many of them are disappointed to see how difficult life on earth is, how much disappointment has to be wept away in the beginning before they get used to life on earth. So this world of second intelligence cannot be that bad. Probably the differences between here and there are enormous. But also our life on earth must have something that is worth giving up so much of the other. We even suspect that it is always the same spiritual beings that go back to earth. Once on earth they want to go again and again, despite the physical fetters and great restrictions. An intelligence that was already connected to a body on earth before and now wants to go back, helps from the beginning to fill a fertilized egg cell with life, to order and control the further sharing and to animate everything in it. It may well be that we or our associated network returns to earth again and again, that we are reincarnated. We may have been on earth many times before, but we can only remember it intuitively. Just like in the phases when we are sleeping but not dreaming. Then we often have solutions in us the next morning. We know after sleeping how to get out of our crisis or how it should continue in general. The nets have not forgotten who we once were and let us become smarter and better or fill us with powerful emotions, if we let them. But conversely, there is also the threat that we will spoil our own future if we exploit the earth only for our present time and do not care about the future. What will we find if we are reborn sometime after our death, physically starting all over again and slowly realizing how inhospitable this Earth of ours has become. If the many layers of complexity, these enormous networks and ancient intelligences really exist, intelligences that can influence our physical matter, then it is quite possible that much more is possible than we believe in our current worldview. If life is in symbiosis with these intelligences, which in their eternity are looking for the short while and are constantly working to shape and form the universe in a varied way, then it is also possible that we are reborn. Then we get to feel the consequences of our actions on our own body and are called to account. But then we are not alone, and death is not the end of everything, and therein lies a great comfort.